Hello, I'm Kyle Goodrich, the president and founder of TCarta. Today, I'm going to provide a briefing on the growing issue in maritime geospatial intelligence. Digital does not equal modern at sea. Maritime safety issues with 150-year-old information on modern electronic navigational systems. Now, most people think the ocean is already mapped. Marie Tharp is famously cited for painstakingly compiling and publishing the first complete map of the oceans decades ago. And anyone can download Google Earth and visualize ocean depths in great detail and spin it around, and it looks completely mapped, right? But the hard truth of the matter is only 26.1% of the ocean is mapped with true measurements. The remainder is approximated, estimated, or interpolated, and generally inaccurate. The challenge in ocean mapping is that existing methods for mapping the sea include crewed ocean vessels, airborne LiDAR systems, and unmanned surface or underwater vessels. All require mobilization of equipment and/or people to the location to conduct hydrographic mapping. This makes these methods time-consuming, costly, and potentially hazardous to life and the environment. They also generally burn fossil fuels and require expensive equipment. This leaves a considerable gap in coastal mapping in particular, where source data on nautical charts is often very old and outdated due to the complexity, high cost, and challenges of surveying with these sensors in these areas. As you can see on the left of Tiburon Atoll in the nation of Kiribati, where the last time this island was surveyed was HMS Challenger in the late 1800s. In the lower right, you can see a nautical chart in Greenland, where the information on it is mostly blank and all white space. There's very little information to guide the mariner for safe navigation. And the nautical chart source diagram from Fiji that shows a mixture of data sources spanning decades, even centuries, back to the mid-1800s. This information persists on nautical charts today. Now, space-based alternatives exist in satellite-derived bathymetry, and this technique is celebrating its 50th anniversary this year. Jacques Cousteau and NASA famously teamed up in 1975 using the Landsat 1 satellite image to map water depths of 22 meters in the Bahamas. Today, in 2025, modern sensors and satellite platforms with high-powered computing have transformed this technology to achieve high-resolution, accurate, and validated results derived from space, eliminating the need to mobilize equipment and people to survey these locations. On the left is the same atoll in Kiribati, mapped in high resolution using Maxar's WorldView 2 satellite, showing a high level of detail in the lagoon. This outdated and sparse information on nautical charts have real-world consequences and impact on both commercial and military vessels, which are increasingly operating in unfamiliar, congested, and contested waters. In September 2024, the U.S. Bighorn ran aground offshore Oman. This vessel, a replenishing oiler, was supporting carrier operations in the Red Sea against the Houthis and was disabled due to the grounding that damaged its rudder, flooding the vessel, requiring a tow back to port. This left the Abraham Lincoln Carrier Strike Group without a refuel supply for ongoing aircraft operations in the region. Similarly, in the Canadian Arctic in 2018, a research vessel ran aground on an unmarked shoal while within the navigational corridor. Indicated by the purple circle, the shoal was clearly visible and mappable from satellite imagery just days before the accident, but there was no indication on the nautical chart of any hazards. This is a persistent issue in the Arctic because mobilization of survey vessels and aircraft to this location is extremely challenging due to lack of ports and airstrips, in addition to short season and environmental challenges. However, satellite-derived bathymetry can map these areas rapidly and entirely remotely, providing valuable information and reconnaissance to avoid mishaps and rescue operations. This is also the case in the Pacific Ocean, where in June 2024, a patrol boat on its maiden voyage ran aground in Fulaga, Fiji, as it transited a channel to enter a lagoon. This image collected by Maxar shortly after the incident shows the vessel stuck on the reef. Now, these groundings are often due to a combination of errors, human mistakes, mechanical failures, and environmental factors. However, the issue remains that the vessel was stuck on the reef for nearly 4 weeks and required salvage vessels to mobilize nearly 1,500 nautical miles to the location. When the salvage vessels arrived, the chart on the left is the electronic nautical chart they were navigating by, with source information from the 1870s that provide almost no information on the water depths or the channel. On the right, you can see an updated nautical chart produced from satellite imagery from 2024 that provides considerably more detail and information to the mariner to support salvage operations to pull this vessel off the reef and tow it back to port. These are just 3 examples of inadequate information on nautical charts that contributed to an incident that caused damage to property and the environment, and how information from satellites can improve safety of navigation globally. Satellite drive bathymetry can be produced at high resolution from commercially sourced satellite imagery, but also from open source imagery at low resolution. But you don't have to take my word for it. This is an excerpt from a recent article from the Chinese government using freely available satellite imagery from the United States government to produce satellite drive bathymetry to spy on their neighbors in the highly contested waters of the South China Sea. This is a growing capability around the world and a threat to U.S. maritime operations if the United States does not adopt this technology within our nautical charts. If China is using U.S. government-owned operated satellites for global geospatial intelligence, shouldn't the United States? As you can see on the left in this example in the Scarborough Shoal in the South China Sea, the existing nautical chart from the United States government is entirely blank within this reef. In the center, you can see a satellite image transformed into bathymetry using physics-based remote sensing algorithms and machine learning to produce an accurate and validated water depths from a satellite image. And then on the right, you can see an updated nautical chart produced from this modern information, providing the detail necessary to properly inform the mariner in this location, all produced without the mobilization of people or equipment to this location. Satellite drive bathymetry can play a vital role in the future of nautical charting, especially as our commercial vessels and gray ships transit and conduct operations in Arctic and remote locations. I hope that you can see the call to action here to update our nautical charts and modernize our approach to geospatial intelligence at sea and provide the modern mariner with modern information to navigate upon. Thank you very much for joining me today. Please contact me if you'd like to discuss this topic further. Have a good day.